back. Higher derivatives. If f is a differentiable function, then its derivative f prime is also a function. So you can take derivative of f prime. It is denoted by f double prime, double prime. This new function f double prime is called the second derivative. Okay. Using in Leibniz notation, you would say d by dx of dy dx. So instead of writing so much, you simply say second derivative with respect to x. So notice the 2 goes above d, 2 goes above x. It's just read second derivative of y with respect to x. Okay. If f is x cubed to minus x, find f double prime and interpret it. All right. The first derivative is 3x squared minus 1. This was calculated earlier. Now, second derivative is the derivative of this guy. So, you're going to use the same definition. So, you have f prime now because you're taking derivative of f prime. You go through the same procedure and you get 6x. Here are the graphs of f, f prime, and f double prime. So, f, okay, f prime, and f double prime. Okay, so let's understand this. F double prime is the slope of f prime at the point x f prime. In other words, it is rate of change of the slope of the original. So rate of change of the slope. F double prime is negative when f prime itself has negative slope. F double prime is positive when f prime has positive slope. Okay, so we are looking at second derivative. So in other words, where was that picture? You see, f is the one in blue. F prime is one in pink or purple. Where is f prime 0? When the slope of f is 0. Okay. When f is increasing, so the slope is positive, my f prime is above the x-axis. When f is decreasing, my f prime is below the x-axis. All right, we got this far. Now look at f prime. When is the slope of f prime 0? Slope. Slope of f prime is 0 here. Therefore, its derivative is 0 there. Look to the left of 0 for f prime. It is decreasing. In other words, all the slopes here are negative for f prime. Slope of f prime is f double prime. So f double prime is below x-axis to the left. From 0 onwards, f prime is increasing. So slopes are all positive. So f double prime is above x-axis to the right of 0. Okay. It takes getting used to, but I hope you get good at it. Okay. All right, that was the discussion there. Now, second derivative is also called acceleration, because what is acceleration? It is a rate of change of the rate. So when you are driving at 30 miles per hour and then you accelerate to 45 miles per hour, you have accelerated. So your rate, your speed, your velocity itself has increased from 30 to 45. Hence the name acceleration. Acceleration is rate of change of rate of change. Okay. If S is St, is the position function, its first derivative is represented by velocity Vt. Vt is S prime t. Instantaneous rate of change of velocity. So rate of change of velocity with respect to time is called acceleration. So acceleration is first derivative of velocity, which is second derivative of position. In Leibniz notation, A is dv dt or d2s dt squared. Okay. The third derivative of second derivative. Okay. Third derivative is the derivative of second derivative. It is the rate of change of second derivative. So you write it as d3 dx cubed or f triple prime d by dx of d2y dx squared. So all these are acceptable notations. The first two, Newton, these two, Leibniz. Okay. The third derivative of position is the derivative of acceleration, and that function is called the jerk function. Okay. The jerk J is the rate of change of acceleration. It's aptly named because a large jerk means a sudden change in acceleration. All right. This differentiation process can be continued. Fourth derivative, 4 primes. It's denoted by with parenthesis. Don't forget parenthesis. Without parenthesis, it's simply fourth power of a function. With parenthesis, it is the fourth derivative. In general, higher and higher derivatives, say nth derivative, you would write parenthesis n on top. Do not confuse derivative with power. It's the nth derivative. So you are taking derivative n times. All right. And this is the Leibniz notation for nth derivative. dny dx power n, or this is the Newton notation, nth derivative of f at x. All right. So this completes lecture slides for section 2.2. Next videos will go over problems from web work. Until then.